Today we are talking about geometric sequences. So yesterday we talked about arithmetic, and remind me what happens in an arithmetic sequence.
The difference between the 2 points that are right next to each other is the same.
The difference between terms is constant, or another way of saying is we're adding the same thing every time. So in a geometric, the ratio between terms is constant, or we could say we are multiplying by the same thing every time. What we are multiplying by as we go from term to term is called our constant ratio, and we use the letter R for that. So our first question is decide whether or not this thing is geometric. So to get from 1 to 2, what do I multiply by? 2, and then 2 to 6, I multiply by 3, and if we continue 4, 5, there's a pattern to what we are multiplying by, but we are not multiplying by the same thing. So this is not geometric. And our explanation in our homework would be to say that there is no common ratio. Is this one geometric? What do I multiply by to get from 81 to 27? 1/3. We always need to think about what we are multiplying by. So if you're tempted to think about division, instead think about a fraction of multiplication. So we are multiplying by 1/3. Does that continue to work? 27 to 9, 9 to 3, 3 to 1. It is 1/3 every time, so this one would be yes. And our explanation would be that that ratio is 1/3. Yes?
So it's not geometric if the numbers are different each time?
It has to be the same ratio each time. So even if there's a pattern to what we're multiplying by, it has to be the same by. Is this one geometric? If so, what are we multiplying by? -2. So this one is because each time we multiply by -2. And last one, is this geometric? Why not? Okay, so we have some problems with negatives. So here we're multiplying by 3, here by -3, here by 3, here by -3. So it's close, but those negatives aren't quite working out. So there's no common ratio here. It has to be exactly the same thing we're multiplying by each time. Questions? This is our formula for a geometric sequence. Like yesterday, a sub 1 means first term. And R is our ratio. N and a sub n minus 1 are variables. So they should be present in our rule. There should still be an n left over in your rule. You do not need to have this memorized for the test. So like the one yesterday, you don't need to worry about committing it to memory. So this question asks us to write the rule and then to find a sub 8 or the 8th term. So that formula, again, is a sub 1 r to the n minus 1. So what is a sub 1? R is the common ratio, which is what we are multiplying by from term to term. So what do we multiply by here? 3/2. If you find it difficult to see what the common ratio is, it's a ratio, which means division of terms. So to find your ratio, you can take any term and divide it by the term before it, and reducing that fraction will give you your ratio. So sometimes you can look at it and just tell, I'm multiplying by 2 or I'm multiplying by 3, but if you can't really tell what you're multiplying by, dividing a term by the term that comes before it will give you your ratio. So our ratio in this one is 3/2. And then our formula says to the n minus 1. And that is actually it. Do not try to do any simplifying on this formula. I'm not saying that just to make your lives easier or to be nice, but it's actually wrong to do it. Order of operations says that we need to take care of exponents before we could multiply or divide. And we can't do the exponent here because it has a variable in it, so we don't know what the exponent is. So you cannot multiply that 8 and 3/2 together. It's wrong. Okay, you'll get wrong answers at that point. So I'm not saying just don't do it to save you a step. It's actually wrong if you do it. Okay, so leave it just there. Don't try to multiply those together. Then we are asked to find a sub 8, which is the 8th term, or what we get when we plug in 8 for n. So then on the calculator, I'm going to do a negative 8 times a 1.5 to the power of 7. Which gives negative 136.6875. Questions? Go ahead and try this one. Okay, so to write our rule, a sub n equals a sub 1 means first term, which is 5. Ratio is found by dividing terms, so 2 divided by 5 gives us our ratio. If you put that as a decimal as 0.4, that's fine because it's a good, clean decimal. If it's something like a third and you have that repeating decimal, that's something you have to be careful about. But this is a good, clean decimal, so 0.4 would be fine, to the power of n minus 1. And we leave it right there. We don't multiply it together and make it 2. Then we want a sub 8, which is what we get by plugging in an 8 for n. So we'll do 5 times 2/5, or 0.4 to the power of 7. We get 0.008192. Questions?
I got 128.
And make sure you do parentheses around the 2/5 if you use 2/5. Otherwise, it'll just raise part of it to the exponent. This one asks us to just write a rule, so we don't have any terms to find afterwards in this one. But we are not given our first term. We are given a term, but we're not given our first term. So by being given a random term in the sequence, we are given an a sub n value and an n value. So we are going to plug in 5 for a sub n. A sub 1 we do not know. R we are given is 2. N will be 3 because 5 is the third term, and then minus 1 for the formula. So that gives 2 to the second power, or 4. And dividing out then gives us our first term of 5/4. So adding one step onto the beginning of the previous problem, we have to find our a sub 1 by plugging in 5 as a term and 3 as n because it's the third term that we were given. We then use a sub 1 and r to write our rule like the last problem. 5/4 times 2 to the n minus 1. Okay, so like yesterday, as we progress through these types of problem and the information that we're given, each time is going to add one step onto the beginning of the problem. So in the last problem, we had a sub 1 and we could find r by just dividing two numbers. Here we were not given our a sub 1, so we need to find it by plugging in our term value and the n value. Questions? Try the next one. Okay, so we begin by plugging in a 3 as our term value, and 4 as its place in line. So a sub n is 3, a sub 1 is unknown, r we are given as 3, n is 4, and then minus 1 for the formula. So that gives us 3 to the third power, or 27. And divide out to get our first term is 1/9. Then we use a sub 1 and r to plug into the formula to write our rule. And we cannot multiply that 1/9 times the 3. We just have to leave them as separate parts. Questions?
What's really the way you guys splitting that exponent? Or is it like
It's just the 3 that's taking on the exponent. Yep, the 1/9 does not take on the exponent, which is why we can't multiply them together. So in our final type of problem, we're not given either of the pieces of information that we need for our formula. So for our formula, we need a sub 1 and we need r. And in this problem, we're not given either one of those things. We're given 2 terms in the sequence. So our first step is going to be to find r. R is a ratio or a division of terms. So we are going to begin by dividing the 2 terms that we are given. And that gives us negative 27. But those aren't 2 terms that are right next to each other. So our ratio is not negative 27. But negative 27 is in some way a multiplier here. How far apart are those terms? 3. So what we are going to do is take the type of root as how far apart the terms are. So since we have the second term and the fifth term, they are 3 away from each other in line. So we're going to take the third root. If they were 6 away from each other in line, we would take the 6th root. However far apart, we're going to take that type of root. So the third root of negative 27 is negative 3. That is our ratio. So we take the ratio of the 2 terms that were given, and then take the of the type of how far apart they are from each other. That gives us our ratio. So now this becomes like the previous problem. We have a ratio and we have a term. We actually have 2 terms, so you can just pick whichever one you like better. I usually like the smaller numbers, but it doesn't matter. And plug it in like the last problem. So 45 equals a sub 1 we still don't know. R we just found is negative 3. 45 is the second term, and then minus 1 says the formula. So that gives a first power, so just a negative 3. And divide by the negative 3. Gives us negative 15 for our first term. So then we know first term and r, which are the 2 things that we need to be able to write our formula. So you get negative 15 times negative 3 to the n minus 1. Okay, so we start by finding our ratio, by finding the ratio of the 2 terms that were given, but if they are not right side by side, we then need to of how far apart they are. That's our ratio, and then this becomes like the previous problem, plugging in one of the values and solving for a sub 1. Questions? Try the last one. Start by finding our ratio, which we find by dividing the 2 terms that we are given, which gives us 256. But since those 2 terms are not right next to each other, that is not our ratio. So to find our ratio, we take the root of the type of how far apart they are. So since we have the second and the 6th, they are 4 away from each other in line, so we take the 4th root. And that gives us 4 for our ratio. 4 times 4 times 4 is 256. We then use our ratio and one of the terms, and it does not matter which one, to plug into the rule. So negative 4 equals, we do not know a sub 1. R is 4. N is 2. Then minus 1. That gives us just a first power, so just a 4. And a sub 1 is negative 1 then. Then we use a sub 1 and r to finish out our rule.
Claire,
Yes.
would you send Rebecca Brookins the office, please?
Yep. And so that's our rule. And don't even try to combine that negative in there. It seems like a tempting thing to just be able to throw the negative in with the 4, but they need to stay totally separate. Questions? All right. This is from 11.3. Notice in your homework that for the first questions, it does not just ask you geometric, yes or no. It asks you, is it arithmetic, geometric, or neither? So you need to test with also what we learned yesterday, so a little bit of built-in review there.